Hello everyone, welcome back to the series How to in my class CSC 120. Today I'm going to talk about shifter circuits. In this video, I'm going to show you how to design basic shifter circuits, how to use multiplexers as building blocks to build larger circuits, and how to identify different types of shift operation. So let's start with a very basic shifter. This one is a circuit to test the shifter circuit that I built in this subcircuit right here. It shifts the input, the 4-bit input, either 1 bit to the left or 1 bit to the right based on the value of the shift input right here. If the shift input is 0, then I want to shift the input 1 bit to the left. And if the shift input is 1, then I want to shift the input 1 bit to the right. Today is going to be a little bit different because I'm going to test the circuits I built in this subcircuit first, and then I'm going to show you how I designed that circuit in the later part of the video. So what is exactly this shifter is doing? So in binary numbers, we can shift the numbers 1 bit or maybe another number of bits to either the left or the right to achieve a different number or different values. But right now I'm going to just focus on shifting 1 bit either to the left or the right. So for example, the input A has 4 bits. It can be written as A3, A2, A0, A1, A0, I'm sorry. If I want to shift the input 1 bit to the left, then A3 will be popped out to be the shifter out S right here, and A2 gonna be moved to the left 1 bit, so A3 go to the left, A1 will go to the left 1 bit, A0 will go to the left 1 bit, and the empty space, the empty blank that A0 left behind will be filled with a 0. And the same thing goes for shifting to the right. If I want to shift the input to the right 1 bit, then A0 will be popped out to be the shifter out output, and every other bit in the input will be moved 1 bit to the right, and also A0 will be filled in the blank that A3 left behind. So I have 0, A3, A2, A1 for the output. So let's test the circuits. Okay, so right now I'm having A at all 0, so if I want to shift it 1 bit to the left, the shift input is 0. So it's on still 0. The blank will be filled with a 0 and the output shifter out will be also a 0. Let's change to some value that we can test the circuits. So for instance, right now I have A at 0, 1, 0, 1, and I want to shift it 1 bit to the left. So what do we have? We have 1, 0, 1, 0, right? 0 we're gonna be filled in the blank that the number 1 right here left behind. So it's exactly the output the way I expected. If we want to shift it 1 bit to the right, then we're gonna have 0, 0, 1, 0, and the number 1, the last bit, will be popped out at the output S right here. This is 1. If I change this last bit to 0, then the bit that has been popped out is 0. If I want to change, for example, like 1, 0, 0, 1, and I shift it 1 bit to the right, then I have 0, 1, 0, 0. The last bit 1 is popped out, and the 0 is going to replace the first bit, A3, in the output. So we have 0, 1, 0, 0. Okay, that sounds simple, but it's not quite simple to design this shifter circuit. Alright, and I'm going to show it to you right now in this subcircuit right here. So this is the inside of the circuit that I just tested. It has a 4-bit input, 4-bit output, I control switch LR to select either shifting the input one bit to the left or one bit to the right. And also a shifted output, SO. So let's talk about how I design this circuit based on the function table right here. So for example, the Q3 output, it has two cases. If I shift the input one bit to the left, then Q3 must be the value of A2. Otherwise, if I shift it to the right one bit, then Q3 must be filled with A0. So I have two options for Q3. And the perfect thing to select one of the two input is actually a multiplexer. In this case, it is a 2-to-1 multiplexer that I built in the last video. So what I do is I connect A2 to one pin, A0, D0 actually, I'm sorry, and the ground to the pin number 1. So if I choose the LR switch to 0, then the input 0 here, which is Q2, is the output Q3. Otherwise, if I change this one to 1, then the value of the ground input would be the value of the Q3. And the same thing goes for the other bit of the output. And then also for the shifted output, if I shift one bit to the left, then A3 must be popped out. So A3 is the value of the shifted output. On the other hand, if I shift the input one bit to the right, then A0 is popped out. So A0 is the value of the shifted out. So I do the same things for that output. I use a multiplexer 2-to-1, and I connect A3 to one pin and A0 to another pin, and based on the value of the select input, I can choose the value of the shifted output, and that's it. That is how I design the shifter, the one-bit shifter circuit. Okay, so let's move on to the next circuit. From the shifter circuit that I just showed you, I'm going to expand it and build a larger one. It's also a shifter circuit, but it has 4 modes. It has 4 modes based on the value of the two select input at 1 and 0. And the functions of the circuit is illustrated here on the table on the right. So if the selection input 0, 0, then the circuit will shift the input 1 bit to the left. If the selection is 0, 1, then this output stays the same with the input. If the selection is 1, 0, then the circuit will shift the input 1 bit to the right logically. And if the selection is 1, 1, then we'll do a arithmetic right shift. So what is the difference between a logical shift and arithmetic shift? With a logical shift, we fill in the blank with a 0, but with an arithmetic shift, we keep the value of the highest bit. So for example, if the input is 1, 0, 1, 0, with a logical shift, then we just move 1 bit to the right and fill a 0 in the place at the highest bit. So we have the value of the output is 0, 1, 0, 1. Meanwhile, with an arithmetic shift, we keep the value of the highest bit. So we're gonna have 1, 1, 0, 1 as the output, because we also shift the first 3 bits to the right, but we keep the value of the highest bit the same with the input. So right now I'm having the largest bit here is 1, so I keep 1 as the highest bit of the output. So let's test the circuits first, and then I'm going to show you the inner circuit in this sub-circuit right here later. So let's change the value of the input A to the number 1010 to see if the circuit is working properly as we expected it to be. So right now I'm having the selection input 0 0, which means that I want to shift the input 1 bit to the left, and the circuit use the output 0 1 0 0. Let's see, we're gonna shift the number 1 here out of the input, so it's gonna be popped out and go to the shifted out output, and the 3 bit will go to the left. So we have 0 1 0, and the 0 will fill in the place. So I have 0 1 0 0. If I change the selection input as 0 to 1, then the output is no change at all. So the output stay the same. That's good. Let's change S1 to 1 and S0 to 0. That we do a logical right shift. So I have 0 1 0 1 as the output, exactly the same with the one that we just talked about. And let's change S0 to 1. The circuit will use the output as 1 1 0 1, exactly the same. Let's change the value of A to 0 1 1 0 to see the arithmetic one more time. So we shift the input 1 bit to the right and keep the value of the highest bit at the highest bit of the output. So I'm having the output 0 0 1 1. It does look like logical shift, but it's actually not. If we change the value of the highest bit of the input A to 1, then we shift 1 1 1 to the right, but we keep the value of the highest bit 1 as the highest bit of the output. So we have the output 1 1 1 1, and that's it. That is my checking of the shift foremost circuit. So let's dive in the inner circuit right now. So this is the inside of the shift foremost circuit that we just tested. It looks complicated, I know. But if we can drive the table function like this one, the output will do something like this. If we look closely, each output has 4 options based on the value of the selection input. So let's say for Q3, it has 4 options. If we shift it to the left, then Q3 is A2. If we don't do anything, then Q3 is A3. If we shift this 1 bit to the right logically, then we're gonna fill it with a 0. But with an arithmetic right shift, then we have to keep the value of the highest bit of the input. So Q3 is A3. It has 4 options, so we can use a 4-to-1 multiplexer to achieve that operation. We can connect the 0 of the multiplexer to A2 right here. So it's connected to A2. D1 input to A3. D1 input to A3. Same goes for D3. So D3 is also connected to A3. And for D2, it is connected to the ground. So that is for Q3. You can do the same for Q2, Q1, and Q0. And also the shifted out output. With the shifted out output, when we shift it to, if we don't do anything, then the output is 0 because I don't know what else could it be. So it also has 4 options. So, and we can also use a 4-to-1 multiplexer to get the shifted out output. And that's it. That is how I design the shift foremost circuit. This is very useful to use the multiplexer to shorten the time to selecting bit to have the final output and then also the shifted out output. Alright, Thank you for watching and have a good day.